Hello, everybody. I would like to make a video on probability questions. We looked at some statistics today in class. So here we are, problems 37 and 38. A bag contains 8 blue marbles and 4 red marbles. Ray selects 2 marbles from the bag in succession without replacement. Combine the missing probabilities on the tree diagram below. So first thing that we notice is that there's blue marbles and red marbles, and we already see that the probabilities for those are already set. Since the marbles are drawn without replacement, that means, for example, if the first marble that was drawn was blue, there was 8 out of 12. Well, if we draw another marble and it's blue, we don't have 8, but we have out of 7 and out of 11 in total. So one marble is taken. This probability right here has to add up to 1 together with 7 over 11. So this will be 4 over 11. As far as the red marbles, so we started off with 4 marbles out of 12 was the probability. Then if the first marble drawn is red, probability of second marble drawn being red is 3 over 11. But if what number do we need to add up to 3 over 11? That's 8 over 11. Gives us these two have to add up to 1. So then let's look at the second part. Determine the probability of Ray selecting 2 red marbles. So we're thinking about this probability that the first one is red and second one is red. Now notice how when we have and, we multiply. And there's only one way of getting red and red. So red and red. Okay. We go on the same branch, we multiply. So that's going to be 4 over 12 times 3 over 11. Okay, what is this one going to be? So this will be 12 in the numerator. And 12 times 11 is 132. So this turns out to be, they're both divisible by 12, so it will be 1 over 11. Or you can find out what that is as a decimal. So it's going to be 0.0909, rounded to 3 significant figures. Okay. So the next section is asking us what's the probability of Ray selecting 2 marbles of different color? Well, how can we do that? So that would be the same as first drawing blue and red, second red, or first drawing red and second blue. Okay, every time we say and, we multiply. Every time we say or, we add. All right, let's go ahead and do that. So getting blue and red, blue and then red, that's going to be 8 over 12 times 4 over 11, or, so plus, red and then blue. So that's 4 over 12 times 8 over 11. All right, so when we multiply straight across, we have 32 over 132 plus 32, multiplied straight across, 4 times 8, 32, 32. So that would be 64 over 132, which turns out to be 16 over 33, or approximately 0.485, rounded to 3 significant figures. Next problem says there are 3 pairs of white colored socks and 4 pairs of red colored socks in a draw. Anne picks one sock from the drawer at random and puts it on. She then picks another sock from the drawer and at random and puts it on. Complete the following tree diagram. So from the previous problem, we've already seen that the probabilities for each of these branches add up to 1. So 3/7 plus 4/7 gives us 1. Now, once you draw a white sock, and there was originally 3 pairs of white colored sock, once you draw one, there's only 2 left out of 6. So we have this one is 4 out of 6 since they have to add up to 1. If we start off with 4 red socks, we draw one that's red, so we have 3 out of 6 here, and we have 3 out of 6 here. Next step, find the probability that Anne goes for a walk in the socks of the same color. How can they be the same color? They're either white and white, or red and red. Okay, white and white, 3/7 over 3/7 times 2/6, or plus red and red, so red and red, 4/7 times 3/6. So multiply straight across for the first one. We have 6 out of 42 plus 12 out of 42. So that's 18 out of 42. You can simplify that. It turns out to be 3/6.